Thank you. Yes, I can start.
Welcome.
Thank you for asking me to give this talk here. And coming to Thessaloniki, which is a place I like a lot, to tell you about my work. So I'm going to tell you about the Granagard and its anti-aging and other properties. And you can ask me anything you want after that, and always contact me. Make it work. Okay. Not really. Okay. So the way of life of the ancient man, which life expectancy was 20 to 30 years, was concentrated on obtaining food and escaping from predatory animals and bad weather. That's the way of knowing. He had no time or energy to worry about aging and age-related diseases when all the time you can die from everything that happens around you. So regardless of our modern way of life, biologically, there is no significant difference between the ancient man and us. Our metabolic system still requires or prefers a minimal amount of food and got by significant physical work. These facts did not change because refrigerators were invented together with antibiotic vaccines and heated houses. So, however, this new lifestyle that we have now, as opposed to a few hundred years ago, increased lifespan. Now we live longer. And this is what brought upon us aging and its consequences, including late onset diseases and cognitive and memory decline. This is why sometimes we think in these times and days, we see more cases of Alzheimer, and other diseases, which we didn't know from 50 years ago. So what are the main pathological features of neurodegenerative diseases? First, we have the thing that we focus a lot, and actually there is a talk tonight, I guess, about antibodies against A-beta for Alzheimer, one of the drugs that targets people are working on. And these are misfolded protein aggregate, which are specific for each disease. It's PRP for CJD or prion diseases, A-beta and tau for Alzheimer, synuclein for Parkinson, and others induced overproduction. All of those also produce reactive oxygen species. Mitochondria, the cell organelles regulating most of the energy production in cells, are severely damaged by elevated ROS levels, causing energy failure and cell death. Regulation of energy production and utilization is also the main hallmark of aging. How we use our energy in our cells is what actually makes us live longer or less. So what is the current dogma of aging and neurodegeneration? Aging, obviously, is the greatest risk factor for the development of late onset neurodegeneration, as we just talked about. In the inherited forms of these diseases, while mutant proteins forming the aggregated forms we just talked about are expressed since birth, symptoms and fatal disease appear decades later, indicating there is a role of aging in disease presentation and progression. If so, then we should be able to show that compounds that have been shown to extend longevity, that it has been done in many animals, also in mice and in lower animals like this. For example, one of them is metformin, a diabetic drug that we all know about. They should postpone the onset of neurodegenerative diseases. So how do we measure aging? What can we do? I mean, we cannot do experiments where we say, okay, you should live 80 years, but now let's show that you can live 100 years because there is no scientist going to be alive by then. So obviously it cannot be done. Even in mice, I mean, you have to wait years for results, and it cannot be done this way forever. So people have actually found what are the hallmarks of aging biologically, biochemistry, and molecular biology. And there is all these hallmarks that you can see here, things that we can sell, how many stem cells, what happens to oxidation, all these markers that you can show. And we can actually take cells, so take an animal and take brain and other tissues and find out what happened to the hallmarks. Did they go up? Did they go down? This compound helped them or didn't help them. And this way, you can show that some agent will indeed delay aging. Metformin, for example, which is known to all doctors as an anti-diabetic drug, is not an anti-diabetic drug. It does not act as just by inhibiting from sugar entering the cells, as many people actually thought, but actually by inhibiting gluconeogenesis, which is the mechanism by which we make in our liver new sugar from all kinds of usually proteins and other sugars like that we have in our blood. And the inhibition of gluconeogenesis is made by activation of AMPK, which is one of the main factors of energy in the cells. It's the master energy sensor of cells. When we have him working better, we have anti-aging activity, and most of the aging hallmarks are actually directly by activation of AMPK. So now let's go a little on the side and talk back about neurodegeneration. We are going to go back and forth between aging and neurodegeneration. Is it even possible to cure neurodegenerative diseases? Let's look at it this way. How do we do it? Usually whenever a disease that we have, and from a cold, corona and cancer, whatever you do, there is a disease outside the CNS, you have clinical symptoms, then you go for diagnosis, you have treatment and hopefully recover, and then you can think about going back to normal life. However, when you have a case of progressive neurodegeneration, this is not so anymore. Because the moment you have a diagnosis and before the clinical symptoms, neurons are already damaged at the first time, very high. So there is not going back to normal life, even if at this point you can stop the disease. So actually, you can only think about stopping there in the best case, but usually it's in a very bad state. So what? Prevention, exactly. So what can we do? We need to do preventive treatment for at-risk individuals. This is actually what we want to do for everything in life today in medicine. We want to do prevention. We wanted to do it for COVID with all kinds of measures, from masks to immunization. This is what we want to do for everything in life. And how do you do prevention? You have to test it in the right animal models, which is the model of disease. And then you can tell if something will really prevent it. Okay? So what are the obligatory properties of a preventive treatment? What do we need it to be? So it should be safe for long-time administration to healthy individuals. This is the first. You cannot use anything which has side effect as a preventive treatment that you're going to be used for a brain disease, meaning 20, 30 years, 10 years, whatever. Should be safe. Should be compatible with the maintenance group of drugs. What is a maintenance group of drugs? We older people should take drugs for blood pressure, for diabetes, for cholesterol, everything like this. This is our kit, okay? We need it. So we need something to add to it, which is going to be good for brain diseases. But we need to do the maintenance. As a car needs maintenance, we need maintenance. The price should be reasonable. Obviously, you cannot sell an Alzheimer drug that is developed today would cost $1,000 a month, or $100,000 a month, whatever are the numbers. All these new antibodies which are being developed, if you need it for 50% of the population, which is 80, this is cannot be done, okay? So based on these criteria, we decided to produce a smart food supplement with targeted neuroprotective activity. So you need something safe. You have to take it from something we know, okay, from our environment, which we know is safe, and then show that it's active. Okay. Why pomegranate seed oil? Pomegranate seed oil contains high concentration of prunictic acid, PA, also known as omega-5, which is a polyunsaturated fatty acid with 3 conjugated double bonds, and it's considered one of the strongest natural antioxidants. Prunictic acid is also found in another plant in nature, in China, called Granagard, or whatever name in Chinese that I've never been able to pronounce. It's only 40% of ponicic acid there. And we learned a lot from the research that's been done on the Granagard regarding ponicic acid. Ponicic acid metabolizes in vivo into CLA, 9-11 conjugated phenolic acid, just loses one of the double bonds, which by itself, it's an antioxidant, an anti-calpain inhibitor, which is, and has been shown in cells to delay, to prevent the aggregation of A beta. So consumption of other PA containing oils did not result in accumulation of ponicic acid or CLA in brains. So we know from the work of the Chinese on humans that the ponicic acid goes into CLA in liver and in blood, and we know that nothing gets into the brains, obviously in mice and not in humans. It cannot be tested in humans. So we needed a way, we cannot use it as it is. It obviously was not going to. So what we did is we took the pomegranate seed oil, which has usually big drops, as any oil does, and we added surfactant so we can change it into small oil droplets, and we tested its activity and its metabolism. So what we can see that when we do this, the conversion of PA to CLA in the liver increases by a lot, and the concentration in the brain goes from very little to a lot and stays like this for a long time when we give it to mice, and without causing any side effect of no way, because actually it's an antioxidant that gets into the brain, and whatever it does there doesn't have any side effect. Okay, so formation of small micelles by addition of food-certified surfactants to PSO facilitates the conversion of PA to CLA in the liver and subsequently the targeting into the brain. So there is no magic. We don't do any high technology. We just take the big droplet drops, make into small drops, and this way they have access to conversion into CLA and entrance to the brain. So we have tested this Granagard, which is the form we call nano-PSO, into different animal models, actually quite a lot animal models. We have the Creutzfeldt-Jakob animal model, which we are going to talk about a little bit further, the Alzheimer FDA model, which is a model where mice have introduced, we have introduced vitogenic methods into mice of different proteins that actually all of them, each by themselves, can cause Alzheimer in humans. We have a test for multiple sclerosis mice called EAE. We have also have brain injury mice that have gotten a hit on the head and they lose cognition and lose nerve cells. We have shown here also that Granagard can help a lot. And more recently, we have done experiments where we've transplanted. We have treated different models, CJD and also EAE, the model of multiple sclerosis, by transplantation of endogenous stem cells, and shown that Granagard can have these cells live much longer. And now we want to compare the anti-aging activity, meaning we are going to take this model of Creutzfeldt-Jakob disease. We know a lot about these mice. We have worked on it for years. We know how they react to disease. We know the protein, PRP, the aggregated protein, how it works. We know the energy factors here. And we are going to compare Granagard to metformin, the anti-aging, anti-diabetic drug, which is shown to be one of the great anti-aging compounds, and see what happens to all these aging hallmarks each by one to see if Granagard can really do this. So this is what we do. We do groups of regular mice, heterogenic mice, and treat them for a few months or a few weeks, depending on the experiment, to see how they react. And what we are going to test here is all the anti-aging hallmarks. You see, this is biochemical, immunological, pathological markers, and markers of the disease itself to see if Granagard can treat the anti-aging hallmarks, and if metformin can treat actually Creutzfeldt-Jakob disease. Okay, So this is a complicated Western blot, but just to show you how we did it. This is phospho-AMPK. I told you this is a great marker, AMPK, master energy sensor, whose activation helps maintain cellular energy levels through modulation of homeostasis. So we see that metformin and Granagard work exactly the same. All of them activate, and this is true in lungs, okay? Indeed, we have patients of COPD and stuff like that. They call us in our office and say, you know, I took this Granagard because my mother died of Alzheimer, and then suddenly I feel much better with the lung. My diabetes is lower, all kind of things, because by doing the nanoformulation, we managed to get CLA, maybe the metabolite, into other organs, not only brain. And this is lung and liver, for example, and we are testing our muscles and others. Okay, so we can see see this, but amazingly in brain, we see a different model. AMPK in wild-type brains, you see it's always high. For some reason, I cannot show you this on this. I don't know, this is the way the system works. But in the disease, it's lower. So now we can. Can you tell me how I go back? Because I didn't manage to go back. Can you tell me how I go back? Ah, you are. Okay. No. No. No, you're going forward. I know it wasn't supposed to be, but it is. Number 16. Yeah. Go to number 16. Okay. So we see that actually we can activate AMPK, and in brain it's activated, and in the disease it's lower, and we can make it go back with both agents, also with Granagard and metformin. So it looks very much the same. This is another energy factor. NRF2 is a transcription factor which controls the expression of a variety of antioxidant and detoxifying agents. And we see here too in the disease. Is there any way I can actually show in the slides? Why cannot I do it? Yes, I'm trying to, but it doesn't. Oh, now you see it? No, I don't see it. You see it? I don't see anything. I'm doing it. You see, I'm seeing it here. See here. Yeah, here I can see, but now you can see. Good, good. So you see it's lower in the during the disease, but both treatments actually bring it back. So again, you see another aging hallmark, which is, let's see if now I can go. Yeah, but if I do this, now I cannot go on. From the arrow down? No, it goes back on the other side. It's very strange. Okay, let's do the opposite. Doesn't matter. Okay. Yeah. Okay. That's okay. I'll try. Okay. So this is PRP, the protein which is specific for Creutzfeldt-Jakob disease, and we can see it doesn't change in any way, as we have known for Granagard forever. Metformin also doesn't change it, and okay, it doesn't. And these are other factors again for oxidation. So we see that we have many factors that goes like this, and Granagard behaves very much as metformin for all of them. So both metformin and Granagard elevated HIF and COX levels, which have to do with mitochondrial activity and with anti-aging. Okay, just to show you, this is from the Alzheimer mice. The green is A beta. The protein which is the hallmark of Alzheimer, and all these people doing the drugs do antibodies against it. If you take a mouse model of Alzheimer and treat it with Granagard for several months, you see there is much less green and more COX-4-1, which is the most important protein in mitochondria, which generates energy. And the same goes for inflammation. We also see a reduction of inflammation with both reagents. And this is something very interesting. One of the questions that we really don't understand is why we have stem cells, why our brains have endogenous stem cells, which we thought we need only to do by transplantation for diseases. But it turns out this is nestin, staining by nestin of normal brain. We have stem cells made all the time. And when the disease happens here, this is Creutzfeldt-Jakob, but the same happens in Alzheimer and other brain diseases, these stem cells, the endogenous stem cells, almost disappear. So it's something that has to do with neurodegeneration, that we cannot keep our stem cells alive. And by treatment with both metformin and Granagard, we see that we can revise it and get our stem cells back. This is the basis of the experiment I told you we do with humans and MS. So we have shown that actually Granagard can compete and give us all the factors of anti-aging that metformin does. And this is by a compound that doesn't have any side effects and can be taken for a long time. Metformin is a diabetic drug, and not everybody can take it. And if you take too much of it, you can have other problems. Now, what happens with metformin and the disease and Creutzfeldt-Jakob by themselves? So when we did this, we actually find out that these are the mice. When you treat them with Granagard, we see much lower disease score, and the mice live much longer, but metformin doesn't do it. So actually, we have a very interesting result. Metformin had no effect on disease-specific CJD markers. So let's look at our conclusions by now. Aging and neurodegeneration, it is complicated. Not everything that is anti-aging can be also anti-neurodegeneration. It looks like a good idea, but it's not always true. Anti-aging drugs may delay onset of neurodegeneration, as is the case with Granagard, but it's not true for all of them. In both cases, the mechanism of keeping neurons alive relates to energy activation while reducing oxidative stress and hypoxia. So this is what we need: increase energy, keep our cells alive, increase mitochondrial activity, and this is very important. Bisphosphonated protein aggregates are specific for neurodegeneration, but also they accumulate and cause mitochondrial dysfunction, as I've shown you in also the Alzheimer brain. So can Granagard act as an anti-diabetic drug? Because we have just shown that it is very close to metformin in many ways. Can this be true? And the reason we ask this question is that not only have we done this experiment, but people call us, in the company and say all the time, I'm taking Granagard, as I told you, for COPD, for this and that, but now I am a pre-diabetic person, and instead of having my drugs lower down the sugar to 110, if I take also Granagard, then I find they also lower it to 100. Does it make any sense? And I said, yeah, let's see what happens if we take some animal model of diabetes and test it. So we decided to do this, and this is an Akita model of type 1 diabetes. This is the work we do together with the endocrinology center in Hadassah. And these mice actually are born with a mutated form of insulin that aggregates. It's very close to actually what we think in neurodegeneration, but now it's with insulin. And they develop diabetes days after they are born. So we took these mice and we gave them Granagard for several months, and we looked at what their sugar levels. So we find it doesn't work like a total anti-diabetic drug. Definitely, if you take metformin or other insulin here, you will see sugar low down completely, but it has some effects, adds an effect to the drugs and lowers to some effect. Actually, enzymes that have to do with gluconeogenesis. As I said, this is an important thing that metformin does, inhibits gluconeogenesis, have lowered, at least the key enzyme lowers. We see also a reduction of sugar in urine, and also AMPK in liver is elevated by Granagard. So it has some kind of an anti-diabetic effect, definitely not an anti-diabetic drug, but if you take it, it will add to your sugar balance. So what are the ongoing clinical trials that we have with Granagard? So we already published, and I'll show you now, that MS patients treated with Granagard presented increased memory. Granagard and mild cognitive impairment, in mild cognitive impairment, we have an experiment going on in the Rambam Hospital in Israel, in Haifa, and it's not finished yet, but we can already tell that after a year, the patients which are already a year into the program show no side effects whatsoever and no deterioration also. So we don't know if it's going to be a great result, but definitely a bad result it cannot be. I'll talk about Granagard in carriers of genetic CJD mutations, which is something very interesting that we do. And we had our partners in Mexico are doing a big clinical trial in Parkinson disease, and they may have results actually in a few months. So what happens with multiple sclerosis? So it turns out that multiple sclerosis—
You have to complete, please.
I have to complete. I need 2 more minutes.
Because we have a question also.
2 more minutes, okay? So in multiple sclerosis, usually this is disease that we know the physical effects, but we don't know that people with multiple sclerosis also develop dementia with time and cognitive disorders. So we have done an experiment where we treated people with Granagard together with their treatment and test them for cognitive and abilities and memory after 3 months and after 6 months. And we have found a 12% improvement in memory. Just for lack of time, I'm not going to show you everything, but you can go and look at the paper. The group that Dimitri Karoussis group in Jerusalem has done. Everybody that wants it, I can sell him the paper fast. And we are also now, as I told you, testing. I'll skip the animal work here just to show you that this is human cells transplanted into mice with MS, and they are still alive, while without Granagard, they're not alive after a few months of experiment, which is, and they are doing it now in humans. And as I said, we are doing this with MCI patient, and results are still coming, but they may look okay. And now just let me tell you one thing about the CJD patients. It's very difficult CJD is a terrible disease. It's like an accelerated Alzheimer. People come to you and say, I don't forget, I forget that, I cannot do that, and in 2 months, they're almost dead. And obviously, there is no time for treatment of the patients. But if it's a genetic disease, then you have all the community, their children, their grandchildren, their brothers and sisters and everything, which may carry the mutation, which is a dominant. So 50% will carry the mutation, and they will be sick at some point. So actually, our work is devoted to them. And how do you test this? I mean, how do you take a community and give them a drug and say, let's wait 10 years, 15 years, and see what happens? So obviously, this cannot be done. So what you can do is tell these people, we recommend this for you. It is good in mice. You know, we've done it in estrogenic mice exactly like you, and see what happens. And then look every year to see how many of the new patients were those with Granagard and those that didn't take Granagard. This you can do and make some calculations. So this is what we have done together with the CJD clinic in Ichilov. There are 2 women doctors that take care of all these families. And in the last 5 years, since Granagard has been on the market, okay, there were about 70 genetic patients between 218 and now. We know that 30% of the families take Granagard because this what they are asked in the clinic. And this implies that we would expect 10 to 11, 12 patients from there to now that were taking Granagard if Granagard doesn't do anything. And we only have 2 confirmed patients taking Granagard. So it looks like it's doing something.
Please, you can complete your presentation.
Yeah, of course.
We have no
and this is what we have now. We also have less patients than expected in the country in these years. These are the people that collaborate with me. And thank you very much.
Thank you too, me too, for this interesting presentation. And I will call the audience to make the questions now.
Yes.
Congratulations. This was very good presentation and very informative about the mechanisms, how this oil can work. I have only one question. Yeah. Why do you need to prepare this nanotechnology preparation? Did you work with oil of pomegranate alone in order to see if you have the same results?
Yes,
because as you also believe in Israel, there is a God who prepared everything with very much wisdom. So
if I have 2 minutes, I'll explain.
Okay.
We started this project of all the wrong reasons. I had this mice model and I was looking for an antioxidant liquid. And one day I bought this strip for the face from a company called Lavido that has a large quantity of pomegranate seed oil. And after a few weeks, people started asking me, what do I put in my face? And I said, okay. I looked and I said, oh, pomegranate seed oil. And I looked at the chemistry. I'm a chemist from the basics. So it looks good to me. I called them up and I said, can I have a bottle of your oil? I want to give it to my mice. And they sent me a bottle. And I gave them to the mice in the food. And we did an experiment 3 months and we saw a little difference in the score going up of them. And I said, no, not good. Okay? It's good. It's a way, but it's not good. And I talked to it with my husband, which is an expert in nanotechnology for cancer. When he said, go to Shlomo Magdassi, the chemistry department of the Hebrew University. And I went to him. Yes. And we made the nanoform and it worked.
Yes, but you know very, very well, as we know, that what happens in animals doesn't work every time to human beings. So we have the opportunity to hear now a clinical study with the physical pomegranate oil from seeds of pomegranate, where we have also very good results. So let's go on.
Yes. Next question, please.
Oh, more questions?
Is there any question, please?
No, we can hear the second talker then.
Yes.